Hello, discrete math fans. Let's talk about contradictions and valid arguments. The concept of logical contradiction can be used to make inferences through a technique called the contradiction rule. The contradiction rule says that if you can show that the supposition that the statement not P leads logically to a contradiction, then you can conclude that P is true. We're going to be using this contradiction rule as a proof technique later on in the class. So just as an example to illustrate the contradiction rule itself, let's show that this argument form is valid. And we're going to use C to represent a contradiction. So this has just one premise, which says not P implies C, therefore P. Remember that C, you can think of it, if you'd like, as a variable that's always false. Okay, here's the usual thing. We'll use a truth table. Notice that the column for C is simply always false. Maybe I shouldn't even call it a variable. It's just always false. There's only one premise. The premise is not P implies C. And then we have to find the critical rows. The critical rows are the ones in which all of the premises are true. There's only one premise, and so there's only one row in which all of the premises are true, and that's this one. And the conclusion in that row is true. Therefore, we can say that this argument form is valid. Notice that I didn't finish the truth table. What's going on here? Well, we don't really care. All we have to worry about is what happens when the premises are true. We don't really care about what happens when the premises are false. It won't matter for trying to prove that an argument form is valid. Okay, that's all for now.